All right, guys, so welcome to 4.3. 4.3, we're going to look at different types of data. We're going to look specifically at three different types. And this is like the three main ways that we'll store data throughout this course. So I just want to make sure that you are aware of these things because later on in the course, you're going to actually need to specify to Python what you expect these data types to be used as so Python can actually do things with them. So we're going to start with a really quick example, and we're going to see it fail, and then we're going to fix it. All right? So let's say we have a person who is 23 years old. So we put age equals 23, and then we're going to print you are plus age plus year, oh, that should be in quotes, years old. All right? So we have this piece of code we want to run. You are 23 is supposed to be the number put in here, years old. Let's try running this and see what happens. Yep, we got yelled at. All right. Type error. Okay. You can only concatenate str, not int, to str. All right. So what is this str and int, and why can't we concatenate them together? Whatever that means. So what we have here is we have two different types of data. Notice how age right now doesn't have any quotes on it. So we're basically making this or communicating to Python that this is a mathematical number. One way to fix it could be to throw quotes on it. All right, this should work just fine because instead of being 23 a mathematical number, we just want 23 to show up. But what if I want to do something like you are plus age years old. I want to print next year you will be plus age plus 1 plus years old. All right. So now if I try to run this, we're getting some concatenate errors again. So I know this is a very simple program, but this is a great example that demonstrates why we need to be very specific with our types of code. All right. So let's just put a comment sign behind this so we don't look at that yet. Let's solve this first issue, then we'll come back to that and figure out what we need to do to fix that. All right. So in Python, we have three different types of data. The first thing that we have is string data. And that's anything that we put in quotes, double quotes or single quotes, whichever one you feel comfortable using. There's arguments for using both. But the main idea is with string, we're not going to do any mathematics with it. It's just text. It is a string of text that exists and just does stuff in the text universe. We don't need to add things or multiply things or divide things. Basically, no math needs to happen with strings. So I'm going to put that up here, no math. So we could have hello, the word hello again in single quotes. We could have your name. We could have things even such as, let's say, a credit card number. This is not a real number. Don't try to run it. All right. So we have like a credit card number right here. Now, we're not doing any mathematics to it, so if we store it as string data, that's not going to be the end of the world. And what's really nice about that is when we store the data, those dashes, in the string world, they're just dashes. But in the math world, they're subtraction. So we don't want that type of chaos to be put in with certain types of data. What if we also want to put in a phone number? That looks, 1, 2, 3, 4, 5, there we go. That's a phone number that you could run, right? You don't want to do mathematics. If you add 3 to a phone number, you're going to get a different phone number. All right. Same thing with zip codes, student ID numbers. Any of these different things really should not be considered as mathematics-based numbers. All right. So that's the first one that we have. The string basically means no math, and we have to use quotes. All right. That's the first one that we want to look at. The second one that we have is integers. You probably remember these from your math class. Hopefully you remember what they are. If you don't, here's a real quick summary of them. They're all the positive and negative numbers, 0 included, with no decimals attached. So for example, 42, 17, negative 1, trillion looks like, negative 4, 78. Any of these numbers are integers because they don't have a decimal. That no longer becomes an integer if we do that. All right. Integers are good for doing a lot of different types of simple, quick calculations with solid numbers. One thing that I think is like a really good way to look at integers is if you're playing a game, sometimes you have like a player score, right? The score doesn't go into decimals. It just counts as numbers and points and things that just keep going up in value, hopefully, if you're good at a game. So those are integers, all right? You can lose points. The integers interact with each other. Integers added, subtracted, multiplied. They always give you more integers, so they're not going to break you out of that world. And the last one that we want to look at is float. All right, float type data uses floating decimal points, hence the name. So for example, 78.223 is a float value because we threw in this whole decimal attached to it. Basically, if we have an integer like 78, Python knows to reserve a certain amount of space within its like coding. All right, but if we talk about floating, we have to store the space, but we also have to consider there's another set of data attached to the number, which is the decimal value. So we need to have the actual value of the integer-based number, and then we need to float some extra space for decimals. Those of you who are high-end computer scientists, people high up in the data field, are probably pulling their hair, yelling at me right now, telling me how wrong I am. For this course, we're going to use that as our analogy, all right? It's not a perfect definition, but it does help us understand that we need to float extra space for decimals, all right? So, how can we fix this type of code knowing that we have that type of data? Well, we do want to do math because we have this piece of code eventually closing in on us that we have to solve as well. There's a lot of solutions. We're going to look at the solution where we can temporarily convert one type of data into another to make sure that it can show up inside of a print statement. All right. So what we have here is UR plus age plus years old. This is string data because it's in quotes plus age. Well, we look up here, since it doesn't have quotes, Python's going to assume this is an integer, and then plus, in quote, years old. Okay? So what we need to do is we need to tell age to become a string. And it's really easy to do that. You str parentheses around the entire thing you want to be temporarily converted to a string, and then this should work. Let's try running it. Okay? Boom, you are 23 years old. We got two types of different data to play with each other. Awesome. All right, so now let's try to fix this second part of our program. So it looks like all that I have to do is str around the thing that I want to become the string. Let's try it. Okay, we run this guy. And down here at the bottom, can only concatenate str, not int, to str. Okay, so let's go back and figure out what happened. We thought we had it. We're so close. All right, I'm going to drop these extra parentheses here. I noticed that I tossed in a couple extra. This might help clarify the issue a little bit. So now, next year you will be, that's string data, that's fine. Python should handle that just fine, plus the string of the age, okay, so that's 23, so that'll get turned into 23 instead of the math value of 23, plus 1. Oh, this 1 could be the issue. Okay, let's try what we learned before. Maybe this will work if we string the 1 and then plus years old. Let's see how this runs for us. Okay, you are 23 years old. Next year you will be 231 years old. Something's wrong here, but we're making progress. We eliminated an error. All right, let's go back and see what we got. All right, next year you will be plus string of age. That'll be 23, and then plus 1. Okay, so that's how we got the 2, 3, and then the 1, and they all got snapped together. That's how we got 231. So what I'm going to do instead, I'm going to keep this string parentheses in the beginning here. I'm going to remove this closed off parentheses, and I'm also going to remove the string there. So now let's take a look at how Python handles this, all right? Next year you will be plus the string of the entire thing, age plus 1. Oh, look at that. Now Python sees that it's an integer plus an integer. So in here, it's going to be 23 plus 1. That inside the parentheses, remember, PEMDAS, the order of operations, PEMDAS, the parentheses are going to force whatever's inside of it to calculate out first. There's some of our old math concepts coming back together to make this work. All right, so now age plus 1, so that's 23 plus 1 gives us 24. Then that whole thing is going to get stringed, and then we're going to add it to years old. I think this will do it. Let's try. Okay. Boom. You are 23 years old. Next year you will be 24 years old. Success. All right, we got it running. This is a little tricky. As of right now, yes, we can also, if we wanted to be weird about stuff, we could int items inside of these codes, but that's not going to make sense because now it's string plus int plus these items. Don't worry about that. We're going to get to that when we arrive at that problem. Later in this course, we're going to learn to actually ask the user to type in things into our code. And from there, we can either decide if, hey, Python, whatever they type in is going to be a string, or whatever they type in is going to be an integer, or whatever they type in is going to be a float. All right. The only thing that we need to worry about for this activity is to convert integers and floats, because we can also make this 23.5. I know the numbers don't make sense, but the idea of the mathematical numbers still carry over just fine. Now we're in float territory, and everything works perfect from that. All right. So if you need to put integers or floats in the same print line as any other print statement with some text, you want to put in the str modifier. All right. It temporarily converts it so that it is text-based data. Now, once you string something like this, it no longer can do mathematics because it's not 23 in this situation. It is 23. Just like the word cat is CAT. If you string this, it becomes 23. We are spelling out whatever it was originally as an integer. All right. So just something to keep in mind. So now let's talk about what our little assignment is going to be in this activity. All right. What I'm going to do is I'm going to show you, and I hope you're going to build it with me. You're going to be building a piece of code where you have a restaurant bill. All right. Bill equals, let's say that we owe $165.72. We decided to go on a really nice dinner with 3 or 4 friends, and yeah, that's a little bit of a pricey bill, but hey, sometimes you got to eat well, right? Now, when the bill comes out, it's not just the bill. There's also something else attached to it, which is the tax. All right, I'm going to use some commented code. Tax is let's say 8%. We're going to use easy numbers because we don't need to narrow it down to perfect amounts of tax. Tax is different all across the world in different countries, but 8% is a really, really easy way to figure it out. All right. So what I'm going to do, bill equals 165.72. Tax is 8%. So we're going to make another variable. Tax equals, we're going to calculate the tax on this bill. I'm sure you've seen it before. I'm sure that you've seen that at the bottom of, let's say, a bill, or they will show you how much the tax is that is owed. Well, why don't we build that? Because that's a really cool example in dealing with a little bit of mathematics, and we'll see it come into play for this example as well. All right, so tax equals, well, it's whatever the bill comes out to, right, times 0.08. So I'm going to put that over here. Multiply by 0.08 because we have to convert 8% to a decimal. So when it's 8%, you start here, you go 2 decimals over. Since we don't have a 0 there, we have to plug it in. All right. If it were 9%, it would be 0.09. If it were 15%, it would be 0.15. But we're going to use this as our piece to figure out the tax. So 0.08 times, and let's just plug in that number to see if it can find it out. We're going to enhance it later, but right now we're going to put it in times that number, okay? Again, Python has built-in calculator tools. Let's put them to work. Then I'm going to print All right, let's say bill is, then I'm going to put a $sign right here. End my quotes. So I'm trying to lead up a $sign to show what the bill will be. Plus, now, I want the bill to show up. It's going to be STR of bill. Why is it going to do that? Because bill right here is a float. It's got decimals in it, right? This is meant to be mathematical. So if I put that in and then close it off, my code will now print that information. What I also want to print is tax owed is $, again, end the quotes, plus STR of tax. Now when I run this program, I should get the tax that was calculated. And we have a nice little program from that. Let's see. Bill is $165.72. Tax owed is $13.2576. All right, so $13.26 if we round it. I'll show you how to round at the end of this. Okay, so now let's say the bill up here changes. $175.72. Let's try that. All right, bill is $175.72. Our tax should have gone up, but it didn't. We made a tiny little mistake that we're going to fix right now. See how I put the price here from the old bill? You don't want to have to go in and update more things as you go through your code and build all these different things and features and everything. You don't want to make it, oh no, you have to change the same information in 2 places. That's bad coding. So instead of whatever that number is, why don't we just put in the variable? Now if we run it, the tax has changed. And now every time that I change this bill, let's say it's instead $115.72, and I run it, all right, the tax adjusts accordingly. Okay, so now we've built a nice little sophisticated code. What I can do is, again, set that $sign line right here so I know I never have to go below that. All right, as my bill changes, I go in, I update that one single number, and it updates everything else for me. Now, I'm sure many of you or all of you, or you've at least seen on a receipt, and I'll show you a very quick example, right? Here's an example of a receipt, all right? This person owes $83.12. What they sometimes put at the bottom is a nice way to make it easy so that people can figure out the mathematics of what is owed. So suggested tip amounts are provided for your convenience. 15%, it gives the 15% amount. 18% gives the 18% amount. 20% gives the 20% amount. All right. So what this allows you to do is take a look at this and see exactly what those percentages are. Okay. So if we have that, we can build our own receipt program that takes care of this for us. All right. And that's what we're going to be doing on our next assignment. You're going to have a lot of different features that you can figure out from this. I'm going to show you my piece of code that I've built together. All right. So you've seen all this stuff before already. All right. But there's a lot of code at the bottom. All right. What you're going to do with this code is you are going to be able to type in the bill that's owed at the top and the number of people going out to dinner. And when we run this, a lot of different things get built from it. Okay? First off, obviously the bill. Let me lower this down a little bit so we can actually see what we're supposed to type in and what we get out of it. All right? So bill is $115.72. All right? That is, oh, that's the old one. Sorry, $154.98. That's the bill right here. Number of people equals 4. So in this code, it's actually going to figure out a per person owed down at the bottom with each of those tip amounts that they want to tip. All right. Tax equals 12.3983999999999. Looks like we had some rounding issues, which again, I'm going to show you how to fix. Total bill equals 167.3784. Whatever, these decimals, they're going to go out. Again, I'll show you how to round after. So that adds these two together. So I made a variable called total bill, put that in here. Then I made a calculation on 15% tip. All right, so if you want to give a 15% tip, this is how much you should be paying from there. An 18% tip, how much you should pay from there. And a 20% tip is how much you should pay for the total bill from there. Okay? Now, per person, I've broken down the number of people. So there's some division going on based on how many people are eating here. All right? And it gives how much each person owes if they want to contribute a 15% tip, how much money each person owes if they want to contribute an 18% tip, and how much each person should give if they want to contribute a 20% tip. If I change this number, let's say there's only 3 people out, and I run this, my code should update. This stuff all stays the same because the bill hasn't changed, but the amount that each person owed obviously has to go up because there's less people there. If I change the price of the bill and run it again, everything updates again, where everything gets filled out properly on here. Okay? Now, this is going to look a little sloppy if it shows up on a receipt. So what we want to do, I'm going to run this from another location, is we want it to look nice and neat like that. Looks like I need to fix my total bill, but that's, again, something that I can tap into later and fix. But for example, my 15% tip, well, that gets cut off right on 2 decimal places like all dollar signs do. All right, so we're going to show you, or we're going to take a look at this. Nope, we don't need that. That's the old code. All right, may have to reopen it again. Nope, there it is. All right, I'm going to show you how to do some rounding on just on this piece right here, and then we can take a look at what we're going to do in terms of our assignment and what you're going to do to build it, give you a couple hints and things like that. So there are a lot of ways that we can do rounding, but the basic idea is this is what it looks like: round, and then inside we put the item to be rounded, and then comma, the number of digits that we want to show up. We can put all this stuff together, like do one thing inside of another, inside of another, inside of another, or what I like to do is I'm going to make tax underscore rounded equals round of tax, so that's my variable up here, comma 2. All right, so this says the tax rounded variable is equal to the tax variable rounded to 2 decimal places. And then if we update it in here, tax underscore rounded, now when we print this, we should just get 2 decimal places for the tax rounded. There we go, $9.26. As opposed to, if we took that out and just looked at the old version of the tax, 9.2576, yeah, it did some rounding for us. So it's nice that we can actually do these things that actual receipts do in restaurants. Okay? So your goal or assignment or task to do for this piece is the following items. Let's see, 2 items at the top. We need the bill for the dinner and the number of people. Then from there, what I want you to do is calculate the tax. Let's do at 8%. You can change it if you want. I don't care what you do for that. I trust you're going to figure out a tax rate that's fair. If not, well, your business might not be in compliance with that particular state. Find out your own state's item and go from there. All right, calculate the tax at 8%. Okay. Then we want to find the total bill. So that's going to be another variable that you're going to be creating. All right. Display the tax owed and the total bill. All right. Then I want you to find suggested tip amounts for 15, 18, and 20%. All right. And I'm going to give you a little hint here. 15% turns into 0.15 times the item you want to find the percentage on. All right. Then what I want you to do is display total bill with suggested tip added. So you want to actually show them what it would be, the entire bill with each of those tip amounts. Then I want you to split the bill among each Let's call them guest. All right, let me just make a little bit extra space. Split the bill among each guest and what they would owe if they want to pay 15%, 18%, or 20%. Kind of like what I had before. You want it to kind of mimic this entire thing. So it has the whole bill, all the tax owed, the total bill snapped from there, what the 15% tip would bring it up to, the 18% tip, and the 20% tip, and also show those split per person. If you want to get even a little bit fancier, if you want to show what 15% would be, what 18% would be, and what 20% would be, that might even be an additional feature that you can add onto it. And what's going to happen that's going to be nice is just like in this program, or let me see, oh, no, I closed out the other one. You never have to go below the number sign line because you're going to have the bill and then you're going to have number of people. You never have to change anything else because everything else is always going to be the same mathematical approach. Yes, because this number changes and because this number changes, certain value outputs will change. But again, you never have to go deep into the code to fix a single thing. And that is the beauty of programming. Again, later on in the course, when we learn to ask the user to type in things, we can almost make this like a phone app that figures out and helps you find out the percentage of tip and how much everything is owed and all those different things. All you have to do is type in the data when you ask like 2 questions up at the top. All right, so keep that in mind. If you have any sort of questions on this, you get stuck somewhere, you get some errors, you get some issues, take a deep breath, have a little snack, take a couple minutes to think it through, and then remember, start simple. Do not try to do every single one of these things at once. All right, get the 2 items at the top. Calculate the tax. Do this activity first. This is already getting you about 10% of the way there. Once you get that in, it should be smooth sailing because then you say, okay, what do I want to do next? Well, I need to, I found the tax, display the total bill, I did that, find suggested tip amounts for 15, 18, and 20%. Wait a minute, I was able to find 8%. So finding 15% should also be pretty easy. I should be able to figure that out. Okay, let me get the 15% working. Okay, I think I got it working. Cool. Let me move on to the 18%. All right, 18% now works. Now let me do the 20%. Okay, now 20% works. Okay, now we're in the scenario where I need to split the bill so everybody can figure out what they owe. All right, let me just try splitting the bill if everyone paid 15%. Okay, that works. Cool. I can extend that logic to 18%. Then I can extend that logic to 20%. All right, take your time with it. Build it up. Do some cool stuff. Small steps. And don't be afraid to take a break if you need. This can be a little tricky. It can be a little complicated. It can be a little overwhelming at times. So make sure that you go slow and you pace yourself in a way that you feel comfortable. All right, and when you're done, you will have an awesome application built that helps you figure out some sort of financial issues or problems among people going out to dinner. All right, thanks for watching. Leave your comments in the comments section, and if you're liking this stuff, be sure to subscribe. And yeah, good luck, and I'm excited to see what you build from here.